Okay, so another tactic of solving these logarithmic equations is to use an exponent. Now we're going to look at this one and we're going to see the other equation had a log on each side. This one doesn't. So the method that we want to use is we want to raise each side to that base. And our base, we're going to look at the log for the clue, is a 4. We want to exponentiate it. How do you like that word? That's a good word. So we're going to take this base, which we have a 4, so that's what we're going to use. We're going to use a base of 4. And we're going to make the exponent log base 4, 5x minus 1. And I'm doing that because I want some stuff to cancel. I want to get rid of that log. And the way to get rid of it is to raise it to that base, that same base. And I got to do the same to the other side, 4 to the third. Okay? Now, since I used a base 4, they match. Matching bases, you can cancel out. I am left with 5x minus 1 equals 4 to the third power. And we know 4 to the third power to be 64. Now we're just solving a two-step equation. Add 1 to both sides. Divide by 5. You are left with x equal to 13. Okay, last type of logarithmic equation. This would be something you could see on like ACT tests. What are the solutions of this equation? Now, something smart that you could do, test-taking strategy, is to pick those, plug them in, and see which ones work. But, being Algebra 2 class, we're going to go through the work a little bit. So we're going to take our equation and write it here first. It's always good to pull it out of the problem so that you can work with it a little bit. Now what I see 2 logarithms matching bases. They're not there, so it's got to be base 10. And I see an addition sign from today. We know that when you have 2 logarithms matching bases separated by an addition sign, that goes back to your products property. We can take those two, smush them together, and make it a multiplication problem. A lot of what you guys were doing today, though, is you were writing 2 logs. We only want 1 here. You're just going to change it into 1 logarithm problem. Instead of log of 2x plus that, you're going to go log of 2x times x minus 5. And we're just going to put brackets around it, just because we want that together. Okay? So now we have 1 logarithm, base 10, of this. We're going to go back to our other strategy. We want to try and cancel out this logarithm so that we can work with the x's. How do I do that? I'm going to look at my base. My base is a base 10, even though it's not there. So I'm going to exponentiate it. I'm going to raise it. I'm going to go 10 to the power of each side. When I do that, these bases match. That's going to cancel. I am left with 2x times x minus 5 equal to 100. I'm going to have to do some distributing here. We're going to distribute 2x to my binomial inside. I go 2x squared minus 10x equal to 100. Okay, right away we should be going warning bells. This is a quadratic. So I definitely want to take that 100 and move it back to this side. 2x squared minus 10x minus 100 equals 0. Now, from last chapter, you guys found several different methods of solving these. You can factor, you can graph, you can use the quadratic equation. It's entirely up to you. This is a really easy one to factor. I'm going to notice that all of these can be divided by 2. So I'm going to do that, and I'm going to pull 2 out of my parentheses. I'm going to have 2 times x squared minus 5x minus 50 equals 0. And you can't see that, but we know it's equal to 0. Okay, so I'm going to see if I can factor this one. There's nothing in front of x squared there. And this 2, honestly, kind of drops off, so we can just ignore it for now. I'm going to look and see if I can factor this. I want you guys to take a minute and see if you can factor it on your own, and then we'll resume in just a second. Okay, so if you went through and remembered factoring, or if you did quadratic equation, either way you'll get the same answer. We split these up into x minus 10 and x plus 5. I said what factors of 50, what will multiply to be negative 50 and add to give me negative 5. And that was negative 10 times 5. And that went into my factors. Then you use your zero product rule, set each parentheses equal to 0. We solved and we found 10 and negative 5. Like I said, that 2 kind of just drops off the face of the earth there. If we were to divide both sides by 2, it would 0 out. So we don't care about 2. Now though, you guys see up here, it says extraneous solution. So we have to check that both of these work. Let's start with our 10. We're going to go log 2 times 10 gives me 20 plus log 10 minus 5 gives me 5 equals 2. Okay, I want to check that. Oh, look at that. Addition goes to that multiplication property. Log base 10 of, it's 20 times 5 equals 2. That becomes the log of 100 equals 2. And that becomes something you can very easily check in your calculator. When you do that, okay, we're going to go, log is on the left side of my screen. I'm going to type in log of 100. Let's see if that gives us 2, and it does. So this one checks. So 10 is a solution. Now let's check 2. Negative 5. Let's see if that works. Okay, so we're going to put in negative 5. So here we get log negative 5 times 2 gives me negative 10 there. That negative is going to go in front of your log there. So we get negative 10 plus negative 5 minus 5 is another log of 10 there. Okay, so what I'm doing is I'm plugging in that number into your calculator. Let's say that into your equation. Let's say that you forget that this negative has to go in front of log. It does not matter. If you put your negative here instead and keep those positives, your calculator will tell you the answer. If you try and type in log of negative 10, you're going to get a non-real answer. It's not going to work. So this one, not a solution. Okay? So don't forget, just like all of our other equations, check your answers. Plug them in. Sometimes they will not work.